I'm Jordan.
I'm Kevin.
I'm Emily.
I'm Maddie, and we are the Dewberry group, mentored by Skip Noddy. Our proposed development is for a gas station and our proposed development is for a gas station, combined fast food restaurant, and convenience store in Louisa County, Virginia, which we are flying into right now. The total site area is 3.7 acres, and it's zone C2 commercial, which includes both the restaurant and the gas station as by right uses. So here's our fly-in. This is what we proposed it look like. And there's existing underground electric running on the east side of the site, as well as storm on, this is State Route 15, and there's a storm sewer there. There's an existing 12-inch and 8-inch gravity sewer line running along the south side and the west side of the site that we were able to tie into. And there are no wetlands or historic buildings. We had two conceptual layouts. So they were oriented pretty similarly. The major difference was in the parking. In our first layout, parking was located at the front of the restaurant and then on the south side of the parcel. So traffic flow was in between the parking. This is the layout we ultimately went with, whereas as you can see, there's parking at the front of the site, side of the site, and then offset to the south. So traffic flow is around the parking instead to access the gas pumps. And also the drive-through, which is at the north end of the site. There are 34 included parking spaces, with 2 of them being ADA compliant. And this influenced our grading of the parking lot because we wanted to remain at less than 2% to comply with that. We also wanted to direct runoff not only away from the building, but also away from the gas pumps to avoid the need for an oil-water separator underground. To do this, we have a sag right in between and then a decrease in grade to both the north and the south to direct runoff around the gas pumps and around the buildings at the east and west, respectively. And their steepest slopes occur at the northeast corner and the southwest corner of the site, where our proposed sedimentation basins are, or yes, stormwater basins are. So the roadway grading was heavily influenced by the need to direct runoff away from the existing SR15. And so our road slopes down at 2%, up at a peak, and then down for the remainder. And we took advantage of the existing topography at the end of the road over here. There's natural drainage towards existing wetlands off-site at the undeveloped lot that's adjacent. And the road is designed to be 500 feet in length, with the entrance 400 feet in here, off of the intersection with SR15. And primary consideration also, it was a design speed of 25 miles an hour because it's a local access road. And the other access to the site is through this interconnected parcel up here. That was also a point of consideration for the grading because the change in slope needed to be less than 8% between our parcel and the existing topography of the adjacent parcel.
To begin our stormwater management plan, the site was first delineated into pre- and post watersheds. The rational method was then used to compute all the pre- and post flow volumes for the 2- and 10-year storms. After comparing the pre- and post flows, we decided on 2 stormwater basins to be added to the site. To calculate these sizes, the flow volumes versus the times of concentration were graphed, and then Civil 3D was used to calculate the areas. The resulting areas were about 4,700 cubic feet for the basin closest to State Route 15 and about 1,450 cubic feet for the basin near the back of the site. And as seen here in our stormwater management plan, there are 3 curb cuts as squares, and we use these throughout the site to minimize costs and to convey runoff away from the site. There are also 3 inlets noted by circles that are also used to convey water towards the stormwater basins. There is one to get water away from the road up here at the front. There's another in the front to gather water towards the front basin to tie into the existing stormwater sewer under Route 15, and then one in the rear to push towards the rear basin. We also used 2 pipes that were sized for 10-year peak flow at full volume. An 18-inch concrete pipe was used for the rear basin and a 12-inch concrete pipe for the front basin. All Q values were checked to be greater than the minimum flow in order to prevent sedimentation.
As
As you can see from the conceptual layout, the water and sewer utilities are pretty straightforward. We have existing utilities running along the east and west side of the site. Peak flow for our water was determined to be 500 or 5,000 gallons per day, and minimum pipe cover is 3 feet. For our sewer, again, we tied into the existing. Minimum pipe cover is 6 feet, and both water and sewer maintain a 10-foot horizontal and 18-inch vertical separation. Here's the basic plan view. As you can see, we have existing water flowing along the west side of the site. Sewer runs right along with it here. They tie in 2 feet after the water line ties in. We have a shutoff valve. 6 feet after that, we have a T to a fire hydrant, and then 2 feet after that, we have a pipe reduction to a 3/4 inch pipe. And that runs all the way up to the building, where we have a water meter 2 feet from the building. There's a monitoring manhole on our sewer line at 10 feet, and every 100 feet along our sewer line we have check valve. Erosion and sediment control was done in accordance with the Virginia Erosion and Sediment Control Handbook. It was done in 2 phases, as we will see in the next picture here. This is phase 1. As you can see, we have a silt fence running along the north and east side, as well as down here along State Route 15. We have a sediment basin in the back here. We use that because the drainage area for that was less than 3 acres, meaning that the sediment basin was fully acceptable. We have a material stockpile surrounded by silt fence here. We chose that location because it remains largely undisturbed throughout the entire construction process. Phase 2, our construction entrance from phase 1 still is in place. We've expanded the sediment basin to a drainage basin, and material stockpile is in the same place as stated before. Silt fences have changed to go around the parking lot and along the west side of the site.
For the cost estimate, the major costs for the projects were paving, cut and fill, stormwater management, and ENSC measures. As you can see, this is a cost breakdown. Most of the cost was paving because we used 3 layers of asphalt, each with their own unit costs and volumes. The total cost of the paving was about $212,000. The cut and fill was also very expensive. The off-site soil for the fill alone cost about $95,000. The stormwater system cost about $22,000 for the reinforced concrete pipe and the trenching involved with that pipe. The ENSC measures included the silt fence, the seeding, the fertilizer, as well as the sediment traps and the gravel outlets, and a construction entrance and a wash rack. The total cost of ENSC was about $21,000. Also a notable cost was permitting for connection charges to the existing wet utilities. For our conditional design, the challenge was to cut the cost of the design by 10%, and since the total cost was $415,000, we had to cut costs by 41.5% at least. In our redesigned pavement area, as you can see, we've reduced the amount of pavement here and here. We did that to lower the cost, as well as we also used cheaper alternatives for our valve, seeding, and fertilizer. And we also took out the infiltration basin in the back. We just converted it actually to a traditional stormwater basin. The combined total of all these alternatives exceeds the amount that we needed to save, as you can see. And that is it for our presentation. Do you have any questions?